So I'm not writing this up here by mistake today. It actually is factoring today. Okay, so we are starting factoring today. We're not getting too crazy with our factoring today. There's two types of factoring that we're doing. They're nothing too scary, hopefully. We're going to start with 2x squared minus 15x. This first type of factoring that we're talking about today is actually one that some people started to do on their homework from the first day. When we didn't really need to do it then, but some people were trying. Does anyone remember the first thing you do any single time you try to factor? It's 3 letters. GCF, greatest common factor. The biggest thing that divides out of everything. It's always where we start when we're trying to factor. What's the biggest thing that divides out of both 2x squared and a negative 15x? An x. Just regular x or x to some power? Just regular x. When you are doing greatest common factor, the variable can only be to the smallest power that's in all terms. So x to the first is on the last term. That's all we can pull out. So we write down the greatest common factor, and then in parentheses is what's left after we've factored it out. Now, factoring it out is like dividing it out. So if I divide x out of 2x squared, what am I left with? 2x. What about if I divide it out of negative 15? Or sorry, negative 15x, I meant to say. Yeah, negative 15. Can I factor any further? No. When you do greatest common factor, you always have to check for more factoring. There are times where you will be able to factor further. If it doesn't have an exponent on anything, it's not going to factor further. So, that's it. That's the first one. Not too scary so far? I hope not. Start with GCF. What's the biggest thing that can factor out of all of that? 3, but is it only 3? 3m. If I factor out a 3m, what am I left with? I heard 3m to the power of 3. Okay, what else? Plus 1m, or just m, plus, not 3, 2. Now I have exponents involved, which means it's possible I could factor further. I got an m to the third, I've got a regular m. Generally speaking, there are very few exceptions of when we can factor something further if the exponents don't increase by exactly 1 every time. Exponent of 3 going down to an exponent of 1, not one of the special cases. The only special cases of that we come across that will factor when they jump by more than 1 exponent are difference of squares and either the sum of perfect cubes or the difference of perfect cubes. It's binomials. That's when you have to start checking a little further. Not all binomials with squares will factor further, but for the most part, if it's not a binomial, it's not going to factor further. I've got two more questions that are just focused on the GCF before I switch up and talk about a different type of factoring. Can I factor 2x plus 4? A lot of people, their first instinct is no, because there's no exponents on it. And I did mention earlier you couldn't factor any further if there was no exponents. That doesn't mean you can't do GCF, it might just be numbers. Does something divide out of both 2 and 4? 2. So yes, we can factor this. If we can't factor something, do you remember what we call it? It's an old word. This one can't be factored. I know you can do the rest of it once you know it's 2. Okay, if I think back to elementary school, numbers that don't have factors include 2, 3, 5, 7, 11, 13, 17, 19. Anyone know what these have in common? They're prime. If you cannot factor something, it is prime. These don't have factors other than ones and themselves, technically. A polynomial that cannot be factored can only be divided by 1 and itself, aka its prime. Okay. Last one, that's greatest common factor. Should be pretty straightforward, but it tends to cause some issues. 15x squared plus 5x. Greatest common factor. 5x. Divide by 5x and I am left with 3x plus 1. Far too many people say, oh, 3x, because that cancels out. Things don't disappear completely when you're dividing. When you're dividing, they turn into 1 if you divide something by itself. It doesn't turn into 0. It doesn't disappear. So be careful of that. Okay, other form of factoring we're going to see is for problems that look like this. Now, just like any other problem, the first thing you should check when I ask you to factor is what is the greatest common factor? What's the biggest thing that divides out of all 3 of those? Nothing. You cannot pull an x off because 18 doesn't have an x on it. 7 and 18 don't divide by anything in common, but even if they did, don't forget what number's hiding here. 1. Does 1 divide by anything? No. So this is a quadratic trinomial. Quadratic meaning it's got x squared as its biggest exponent and only exponent. And trinomial meaning it's got 3 terms. Quadratic trinomials factor in 2 ways, AC method or its shortcut. Those sounded familiar? At least the AC method. I am generally the only one that calls it the shortcut because it doesn't have an actual name. Do you remember when to do full AC method versus shortcut? When it's only x squared, when it's 1x squared, in other words. When there's not a number in front of x squared, you can do the shortcut. The shortcut says find 2 numbers that multiply to the constant, but when you add them, you get the coefficient of the term of degree 1. In other words, they multiply to this, but add to that. Things that multiply to 18. If you are completely stuck, ignore the negative and just start counting. 1 times what? 2 times what? 3 times what? 4 times nothing. 5 times nothing. 6 times, I've already looped back around. As soon as this gets bigger or the same as this number, you've gotten all your factors. If you are stuck with which numbers, that's when I do that. It's the only time I do that. I'm guessing some of you probably weren't stuck with which numbers multiply to a negative 18 but add to 7. If it multiplies to a negative, what do you know about your numbers? How do you multiply and get negative? Come on, we know this. Is it positive times positive? Ooh. A positive times a negative. Making one of these negative in a pair, which one's going to add to 7? 9 and specifically negative 2. Now, when you are doing the shortcut to the AC method, you can go directly to the factors at this point. You can go directly to our double parentheses, start them both with the variable, end them with the 2 numbers you found. If you are doing the full AC method, you cannot do that. But we're not talking about the full AC method. The full AC method we're actually going to be talking about on Monday, because that tends to trip people up more. Today we're focusing in on just the straightforward, I can do the shortcut ones. Starting you off fairly easy with the factoring. Try that one out on your own. Okay, what do the numbers have to multiply to? 20. Positive 20. What do they have to add to? Negative 12. What's the only way you get things to multiply to a positive number, but when you add them, you get negatives? They have to be 2 negative numbers. 2 negative numbers that'll work here. Negative 10, negative 2. M minus 10, M minus 2. Almost done, not quite. 3x squared minus 12x minus 15. There's no longer just an x squared. There's a 3 in front of it. Is this going to be a problem? No. How do we approach it? GCF first. Biggest thing that divides out of all three of them? 3. Leaves you with x squared minus 4x minus 5. If you start doing the AC method, because some of you clearly remember the full AC method, and that's great. But if you start with that, you are going to miss getting that greatest common factor. Now, you can always do the GCF at the end. So if you go through all of the work of the full AC method, the greatest common factor will come off at the end still. But you made it a lot more work. Because do I still need to do the full AC method now with that 3 out? No, I can do the shortcut. 2 things that multiply to -5, but when I add them, I get -4. -5, +1. X minus 5, x plus 1. But do not forget, if you did a GCF, put it back on front. One other thing you're going to see is ones that look like this. It's only 2 terms, but there is a squared, which means it might factor. Now here's the thing. You can approach this a couple different ways. You can treat it like it's one of the ones like above. Start with the greatest common factor. Does something divide out of both g squared and 16? And I can treat it like this, like this part of it, because the constant is -16. I'm looking for 2 things that multiply to -16, but when I add them, I get 0, because there's 0 regular g problems involved. I can treat it like this. Or I can recognize that it is a difference of perfect squares. Now, a difference of perfect squares happens when this is something squared. Is that something getting squared? Yeah, the something being a g that got squared. Is this something that got squared? What gets squared to get 16? 4. And is it a difference? Is it subtraction? Yes. Difference of squares will always factor into 2 binomials that start with the first thing that got squared, end with the second thing that got squared. One will be positive and one will be negative. You would get the exact same thing if you were looking for 2 things that multiply to -16 but add to 0. The reason I talk about the shortcut for difference of squares, though, this is that shortcut for difference of squares. The reason that I talk about this separately, even though you can do the shortcut to the AC method on it, is for problems like our very last one. (9x squared minus 25y squared). I still start with greatest common factor if possible. Does something divide off of 9x squared and 25y squared? No. Can I do the shortcut to the AC method on this? Can I look for 2 things that multiply to -25 but add to 0? -5 and 5, but if there's a 9 in front of the x squared, am I allowed to do that? No. Knowing the shortcut for difference of squares is great in those times where the shortcut doesn't apply because there's a number in front of the squared. This one I could do shortcut on, which means shortcut was just as easy. This one, if I want to factor it like a quadratic trinomial, I would have to do the full AC method, which is a longer process if you don't remember it. Is this something getting squared? What do you square to get 9x squared? 3x. Is this something getting squared? 5y. Is it subtraction? Yes. If you can recognize that, that will save you time in factoring. Both parentheses start with the first thing that got squared and end with the second thing that got squared. The symbols in between in factoring a difference of squares, one is positive, one is negative. That saved us a lot of work that could have come out of having to do the full AC method. That's why knowing some of these shortcuts is going to help you out, even if there's another way to do it. We're going to see difference of squares popping up a lot this trimester. It's a very common form of factoring. It's going to pop up quite a bit next trimester. So knowing that shortcut will be helpful.